Let's look at some AP FRQ reviews. This is number 1 off the related rates AP review. Number 1 is non-calculator. A point P, so point P is this point here. Point P with coordinate x, y is moving counterclockwise on a circle with center at 0, 0 and a radius of 5. Part A says when P is at order pair 4, 3 and dx dt is -2, what is dy dt? So first thing is we can start off by creating Pythagorean theorem that relates the two variables together, x and y, because we know that we have to find the derivative and find the equation, find the derivative, and those derivatives will produce these d over dt. Since with related rates, time is the independent variable that's affecting all the other variables. So we start with Pythagorean theorem. We start with x squared plus y squared equals 25. We go ahead and we find the derivative with respect to time. So x squared becomes 2x dx dt. Y squared becomes 2y dy dt. 25 goes to 0. Information that we can pick off from part A. Dx dt is -2. Dy dt is what we're looking for. X equals 4 and y equals 3. We go ahead and replace all these variables with values that we know of. And after we do that, we should be able to isolate dy dt, or recognize that dy dt is the only missing variable, and with value unknown, that we can solve for that variable there. So we get -16 plus 6 dy dt equals 0. Add 16 to both sides, divide both sides by 6. 16 over 6 reduced to be 8/3, so that's dy dt. Part B, what are the signs of dx dt and dy dt in quadrant 2? So let's think about what's happening to x and y as this point moves into quadrant 2 and as it moves towards as to move towards the x-axis again. So if we can imagine that at this point, when it gets into second quadrant to begin with, we're going to have a large y value and a small x value. But as we move towards this side of the circle, we see that the x value is going to be decreasing, right? It's becoming more negative. And also our y value is becoming smaller as well. So dx dt actually is less than 0. It's increasing in value, but it's becoming -1, -2, -3, -4. So therefore less than 0. And dy dt is also getting smaller as well, right? Maybe it's 5, then 4, then 3, then 2. So made a mistake here. So x and y are both becoming smaller. Okay, x and y both becoming smaller. Okay, so x and the y are both getting smaller. Dx dt is becoming more negative, and y is becoming less positive. Okay. Part C, consider the triangle with vertices 0, 0, x, 0, and xy. So again, we can think about this point here. Create a triangle out of that. And part C says use the information from part A to find the rate at which the area of this triangle is changing when P is at order pair 4, 3. So if we want to find the rate of change of area, we have to find the derivative. To find the derivative, notice that we have two variables here that are multiplied, so we have to go through product rule. I'm going to assign the two parts of my product rule there. I'll call the 1/2 x the f function and the y the g function. So once we apply product rule, we can say f prime g plus f g prime. Okay. So f prime, the derivative for 1/2 x is 1/2 dx dt, the original g function. back to the original f function, and then g prime becomes 1 dy dt. Okay. We have the information that we have gathered from part A, so we can just start inserting them in. Dx dt is -2, right? Y is 3. The order pair, yeah, y value is 3. X is 4, and then dy dt from part A is 8/3. So we insert those values in, clean that up. This becomes -3. This becomes 16/3. -3 plus 16/3 is the same thing as -9/3 plus 16/3, which is 7/3. Part D, in the triangle from part C, theta is the angle formed by the hypotenuse and the horizontal leg. When P is at 4,3, find the rate of change of theta. Okay, so we have x and y being the values, being the variables that are changing. As theta is changing, x and y is also changing, but the radius is going to remain at 5, so we know we can let that be a constant. So we're going to have to find d theta dt. That's our goal. So anytime we're involving a rate of change of an angle measure, we have to create a trig equation using either sine, cosine, or tangent. So we can work it either way. You can either do sine theta or cosine theta because we have enough information to put all this in place. Let's start with sine first. If I do sine theta is equal to opposite over hypotenuse, so y/5. And if I want to get to d theta dt, I'm going to find the derivative. So sine of theta becomes cosine theta d theta dt. 1/5 y becomes 1/5 dy dt. We don't know what theta is, but we do know what cosine of theta is. We do know that we can replace that with a ratio. So at this moment in time, when theta is when hypotenuse is 5, we know at this moment in time x is 4 and y is 3. So we can create a trig ratio there. Cosine of theta is adjacent over hypotenuse, so 4/5. So we'll replace cosine theta with 4/5. And then we can replace dy dt with 8/3. That's still something we can bring down from part A. And that leaves us with the only variable missing is d theta dt. We divide the 4/5 over, which is the same thing as multiplying by 5/4. Multiply that through, we get 2/3. Likewise, we can do this starting from the cosine perspective. If we say cosine of theta is equal to 1/5 x, or x/5, we can find the derivative. Cosine becomes negative sine theta d theta dt. Sine of theta for this triangle is opposite over hypotenuse, so 3/5. Replace sine of theta with 3/5. There's a negative that's going to still be included. And then we can replace dx dt with -2. That's from part A. And then we see that the only variable missing is going to be d theta dt. So divide both sides by -3/5, which is the same thing as multiplying by -5/3. Multiply that by -2/5 there. 5's cancel out, negatives cancel out. We're left with 2/3. Either starting point will help us, will arrive at the same answer, 2/3.